Hi everyone, it's Mrs. Bebo. In this video, we're going to continue talking about solving problems that involve proportional relationships by taking a look at a lot more examples that require us to use equations or a proportion to set them up. We really won't use a table or graph too much because most of these examples are going to be better off being solved using the first two methods that I said, the equation or setting up a proportion. So for this first example, Matthew paid $49.45 for 5 used video games of equal cost. The relationship between the number of video games and the total cost is proportional. What is the total cost for 11 used video games? So as I mentioned, I'll actually use both methods just so we can see how both work. I'm going to set up a equation and then on the other side of that, I should say, I'm going to set up a proportion, and both methods are going to yield the same result. So if I'm going to write an equation, remember we need to figure out what k is equal to. So k is equal to y over x. And in this case, I'm going to let y be our total cost, so $49.45. And that's going to be over 5. And then we're just going to divide that out. So $49.45 divided by 5 gives us a k value of $9.89, which again is our unit rate. So this is just telling us that it's $9.89 per video game. So when I write out my equation, y equals 9 89/100 x, x is going to be replaced with this value here, 11, right? Because now we're trying to find the cost for 11. So it's going to say y equals 9 89/100 times 11. And we find out that our total is $108.79. So on that one, we set up the equation. First, we had to find k, set up the equation, and then solved it by replacing the value of x with the 11 and got our final answer. Now, with this proportion method, we're going to find that we're going to end up with the same answer. It's just a different setup. So with that being said, we're going to set up a ratio equal to another ratio. Well, the initial ratio that they give us is that it's 49:45 for 5 games, and we're going to set that equal to the cost of 11 games. So just taking a look at this proportion, I have the cost on the top, and on the bottom is the number of video games. So I'm making sure to keep those values consistent. All right, so now that I have my proportion set up, I'm going to go ahead and do cross products. So we're going to do 49 45/100 times 11, and then we're also going to do 5 times c. So the 49 45/100 times 11 is going to give us a total of 543 95/100, and then 5 times c will just be 5c. And now we just have a one-step equation to solve. To solve this one-step equation, we're going to divide both sides by 5. And we're going to find that our total is $108, or our cost, I should say, is going to be $108.79. So same answer, 2 different ways of solving it. All right, so let's take a look at our next example. So this one says Alicia's class is making care packages for a local shelter. They can make 8 care packages with 240 food items. How many care packages can they make with 510 food items? So again, taking a look at the initial problem, we can make 8 care packages with 240 food items. So this is another example where it actually is set up pretty nice to where you can either use an equation or a proportion. This one I will just use the equation for, just so we can see more practice with that. So again, to set up the equation, we will need to know our ratio of y to x. I'm going to go ahead and let the number of care packages be x and my food items be y. So with that being said, k is going to equal 240 divided by 8, which gives us a value of 30. So basically that tells me that there are 30 food items per package. But I'm going to go ahead and input this into an equation, y equals 30x, because again, remember your equation's always in the form y equals kx. And then I'm going to plug in what I know for this next section, right? How many care packages can they make with 510 food items? Well, I let food items be our y value. So that's actually going to replace y. So it's going to say 510 equals 30x. And then now, again, we just have a one-step equation that we need to solve. So to solve this one-step equation, we're going to divide both sides by what x is being multiplied by. So we'll divide both sides by 30 in this case, and we're going to find out that my final answer is 17 for X. So this just means that we can make 17 care packages. And that's it for that question. Again, you also could have set up a proportion. If you were to set up the proportion, I would set it up something like the following: 240 over 8 equals, again, 510 over the number of care packages. So we do C for care packages. Do your cross products, and then you would find out that the same answer will be found. So the 17 care packages. All right, so for this next example, again, we're solving a problem involving a proportional relationship. This one states that after 2 hours, the air temperature has risen 6 degrees Fahrenheit. The temperature is forecasted to continue to increase at the same rate for the next several hours. At this rate, how many hours will it take the temperature to rise an additional 13 degrees Fahrenheit? So for this question, I'm going to go ahead and set up a proportion to solve, just so that we can see, again, another way of solving it. So we did an equation last time, we'll do a proportion this time. So in the problem, it tells us that after 2 hours, the temperature had risen 6 degrees. So we can put time over the temperature change equals to the time, which is an hour. So I'm going to use H for the number of hours, over, again, the temperature change, which is now an additional 13 degrees Fahrenheit. After I've set up my proportion, we're going to do our cross products. So we're going to do 2 times 13 and 6 times H. 2 times 13 is 26. And that's going to equal 6 times H, which is just 6H. And now we're going to solve this one-step equation. So to get rid of this multiplying by 6 that's going on with our variable, we're going to do the inverse, which is to divide by 6. And then we end up with this 26/6, right? That's not going to turn out to be an even number. So we can simplify this because, again, you're just going to think of this as a fraction, right? So if I write that off to the side quick, 26/6, that's just a fraction. How can I simplify it? Well, both of those values can be divided by 2, and so that would give me a value of 13/3 for the number of hours. Still kind of a weird answer. So when you have an improper fraction that we have simplified as far as possible, we are going to take the time to rewrite this as a mixed number. So 3 goes into 13 4 whole times because that's 12. That gives us 1 left over. So it's 4 1/3 hours for our value of H. So it'll take 4 1/3 hours for the temperature to rise an additional 13 degrees Fahrenheit. All right, for the next example, again, taking a look at this proportional relationship, Brooke bought 8 bottled teas for $13.52. Assume the relationship between the number of bottled teas and total cost in dollars is proportional. How much can Brooke expect to pay for 12 bottled teas? So again, lots of options for this. You choose what works best for you. I will go ahead and set up an equation for this one. So again, need to find our K value, our constant of proportionality first by writing the ratio of Y to X. So I'm going to let Y be my cost, and then the number of bottles of iced tea will be X. So this is going to turn into 13 52/100 over 8. And then we'll just simplify that out by dividing it to find that we get a unit rate of 1 6900. So $1.69 per bottled tea. Writing out my equation, we're going to have Y equals the value of K that I found multiplied by X. I'm going to plug in this case, 12 for X because that is my number of bottles of tea. So this equation is going to be rewritten as 1 6900 times 12. And then multiplying that out, we're going to find that it's going to cost $20.28 for those 12 bottles. And that's it for that question. All right, so moving on to example 6. Again, we're going to solve a problem involving proportional relationships. The aspect ratio is the ratio of width to height of a television screen. A widescreen television screen has an aspect ratio of 16 inches wide to 9 inches high. Using the same aspect ratio, what is the height of a widescreen television screen if the screen is 44 inches wide? So I'm going to set up a proportion on this one. We have our initial ratio here, so 16 inches wide to 9 inches high. So I'm going to write 16 over 9, and I'm just going to make a note to myself that the top value is talking about the width and the bottom value is talking about the height. Because when I set up the other side of this proportion, I do want to make sure that I'm writing those same quantities in the appropriate spots. So the width should be written on the top, which I do know because they tell me it's 44, but I don't know what the height is, so I'm going to use H for height. And then, just like always with proportions, to solve this, we're going to go ahead and do our cross products. So we're going to do 16 times h, which will be 16h, and then 9 times 44, which is going to be 396. And then we just have one more step after this to solve. We're going to divide both sides by 16. And we're going to find that h is going to equal 24 and 75 hundredths. So 24 and 75 hundredths, and their label would be inches. And that's it for that question. All right, so for this next example, we're going to be taking a look at a problem that requires a little bit more work up front. It says at a recent statewide blood drive, the ratio of type O to non-type O donors was 37 to 43. Suppose there are 300 donors at a local blood drive. About how many are type O? So when I look at this initial ratio, they're telling me the type O to non-type O, but they're not telling me the total number of people directly. But if there are 37 type O donors, and then there are 43 of the non-type O donors, we can actually add those together to find out that we have a total of 80 donors in that situation. So we're going to need that information in our ratio because they don't tell us out of the 300 which are the non-type O, right? They just give us a grand total. So we need a grand total based off of that given ratio. So when I set up my proportion, we're going to be looking at, in this problem, specifically type O. So I'm going to be using this value and then this value that I've underlined to set up my proportion. So 37 out of 80, which again, we got the 80 by adding the two types of donors together from the initial ratio. We're going to have 37 to 80, and we're going to set that equal to, again, we don't know how many are type O, so I'm going to just do B for blood drive. If we use O, that might look like a 0 and we could get confused, and then I know for me, my T's look like plus signs, so I try not to use them unless absolutely needed. So I'm going to do B for blood. And then we have a total of 300. So we're trying to figure out of 300, how many were type O. So again, to set up this ratio, we put the number of type O donors on the top. Again, it's unknown in this other situation. And then we have our total number of donors on the bottom. Once I have my proportion set up, I'm going to go ahead and do my cross products. So we're going to do 37 times 300 and then 80 times B. So 37 times 300 is going to give me a grand total of 11,100, and then 80 times B is just 80B, and then we're going to divide both sides by 80 and find out that we get an answer of 138 and 75 hundredths people or donors for those that are type O. Now, it says about how many, and typically with a question like this, it would be nice if it actually said to round. So in this case, we'll actually round down because you can't have 75 hundredths of a person, and if you round up, that's actually going to throw off, again, the number of people. And so a more accurate way of responding to this question would actually be to round down and say that it's going to be 138 people or 38 donors. I would just double check with your teacher what they would require. I know for my students, I say to round down in this situation because if you have 139, that's actually not true. If you're looking for a specific blood type, 139 is going to actually be, you need a quarter of a person more to actually make it 139 donors. So we're going to say it's approximately 138 donors for the final answer on this question. All right, so for this last one, we're taking a look at another situation where we actually are given a grand total, and we have a ratio that does not directly give us that total. So this one says the ratio of 7th grade students to 8th grade students in a soccer league is 17 to 23. If there are 200 students in all, how many are in the 7th grade? So in this given ratio, 17 to 23, they tell us the 7th to the 8th, we can actually get a total number of students by adding those two values together, and that's going to give us a grand total of 40. So now that I know that there are 40 students in total, again, we can set up a proportion to solve. We can also use equivalent ratios because hopefully it's not too bad to see how we go from 40 to 200. But to practice what we've been talking about, we'll go ahead and set up a proportion. We are trying to figure out how many are in the 7th grade, so we want to make sure that we are focusing on the 17 because that is the number of students that are in the 7th grade based on the initial ratio. And then we're also going to use that total that we had calculated. So we're going to write 17 out of 40 equals how many 7th graders out of 200. We're going to go ahead and do our cross products. So we're going to do 17 times 200 and get 3,400 equals, again, 40 times s would just be 40s. And then to solve this, we will divide both sides by 40. And then we're going to get a final answer of 85 7th graders for the number of students. And that is it for this video. Thanks for watching.